when it comes to Move VM, how would you describe it? You're bringing like parallelization for EVM liquidity right now, right? So what is that about?
So for those that don't know, like, Block SDM is the main parallelization engine. It was built by the DM project. And now, like, Monad's consensus is actually based off of Aptos. Solana, we took some lessons from the book, and most parallelization engines are actually based on Block SDM. So Aptos is kind of one of the core contributors to the whole parallelization narrative. I think they just didn't do that better of a job of marketing it, which is unfortunate, but so the thesis behind Move is you're bringing Block SDM, which is the parallelization engine that everyone loves. So all the parallelized narrative that you're seeing right now, as well as security, which arguably is very difficult to sell. It's like privacy, where it's much needed. People need it. People love it. It's a good philosophy for Ethereum. It's not sexy, and there's no like security tokens that pump really, or no privacy tokens that pump. So one of our hardest jobs is making security sexy again, where everyone hates getting hacked. Everyone hates rug pulls, but crypto is so used to like the $50 million hack, $100 million hack, and it's like accepted. When in reality, it shouldn't be. Like, if you ever want Bank of America, if you ever want retail to use crypto, they can't get hacked every week. So the way we're trying to make it is like kind of disguise the security side, make it a part of the stack, focus on the parallelization, the speed narrative. But the reality is we're bringing like the security aspects to Ethereum.
Right. And when it comes to Move, so initially what we saw with Solana as well, right? Like building on Solana was difficult because it was a new language. With Move, it's not a new language, but there are not a lot of people who are building on top of it, right? So how do you like approach that problem?
So we recognize, and actually the way we approach tech stack is that we're fully EVM compatible. So we have an EVM transpiler interpreter called Fractal that lives on top of the VM. So if you're a Solidity developer, you can actually deploy your Solidity smart contracts directly in the VM. It works and looks like an EVM. It doesn't have all the benefits of Move. You don't have as much speed. The security we market is like, if you're writing Solidity, you will not get the security benefits of Move. But it's a way to provide backwards compatibility, which is an issue that even Solana messed up with when we started off with. They're like, you have to write Rust or you're not going to build on top of us. The truth of the matter is all liquidity today, or like 95% liquidity today, is in the EVM and Ethereum. So how do you get the Ethereum people using Move to start off with, and then recognize, hey, Move is better, and convert them? So with the EVM interpreter, we're actually able to cater towards EVM markets while long-term focusing on Move adoption.
Right. And what's the entire tech stack for you guys?
So execution layer, you have our Move EVM, so it's a Move virtual machine from the DM project, made fully EVM compatible. You live on Ethereum for settlement. We use ZK fraud proofs right now for the rollup, but eventually we'll build our own ZK Move VM, but we're working on that. And DA right now is Celestia. And then we have our own shared sequencer, which we call M1. So a lot of different moving pieces.
And when it comes to like the sequencer, you've been very vocal about having like a decentralized sequencer, right?
I think if you look at inscriptions, like every chain broke down. So like ZK Sync, Arbitrum all went down 150 TPS. They'll actually argue that, ZK Sync's arguments, we hit 150 TPS. I'm like, is that a flex? Like, congratulations, you do 150 TPS. Visa's doing like tens of thousands. So like your tech stack probably won't actually scale unless you can parallelize it, bring high throughput blockchains, which they're working on. Like Scroll's working on parallelization now. So I think the thesis is that you want to bring high throughput environments to Ethereum. And that really hasn't been done before.
You have like M1 and M2, right? Which is like the modular layer 1 and modular layer 2. What is like the difference between them, and like how is that playing out?
So we're going to rebrand M2 just movement. So movement is just going to be M2.
Okay.
The thesis was like, we want to create a layer 2 that's a modular layer 2 that uses Move VM with Ethereum as element. And then M1 is a sequencer. So my general thesis is today's sequencers are kind of broken in that they don't do high throughput. There's also no token economic model, where most L2 tokens are meme coins today. But what if there's a world where the validators themselves can stake the token to sequence layer 2, as well as other layer 2s in the network? So like, if I'm a validator right now for like ZK Sync or Arbitrum, there's not much token value accrual. But what if there's a world where I can stake the token to sequence the network and participate in the network? So that's what M1 is. It's essentially a shared sequencer that sequences the layer 2, which is movement, as well as other layer 2s in the network. And we have some pretty big partnerships being announced.
Right. And all right. When it comes to the M1 shared sequencer, right? Like, can you break down that?
So it starts off with the Snowman consensus, which is from Avalanche, actually. The thesis is we want like a very low hardware, decentralized consensus that can scale to multiple nodes. If you look at Solana or some of these other like layer ones, the requirements for running a node are pretty beefy. So it's like you need like a big laptop or computer, and then the minimum stake is a few $1 million. So we want to create a network where anyone can participate with a laptop, stake like a few hundred movement tokens, so not much needed, and then sequence the network. Uses Snowman consensus, it's leaderless, and sequences layer 2, as well as other layer 2s that opt into stake Move stack.